Hello everyone, our project is Automated Human Following Trolley using image and video processing under the guidance of Professor Onraju B, Department of CSE, MIT Mysore. I have my teammates Hemanth Bharath, Likith and Hemanth Raj.
Hello.
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 Now we are going to discuss these following contents. Introduction to our project. Problem statement which we have chosen. Literature survey which we have done to get some idea. Existing system, proposed system which we have come up with to solve the problem. Objectives which we had set to achieve the result, methodology or methods to solve the problem, algorithms used, comparison between existing system and proposed approach, results and overall outcome of our project. Conclusion, concluding how our project went. Moving on to next slide.
Yeah. To give the quick introduction on our project, yeah, in the present world, we can see we use the trolley for various things for carrying goods and other items which are necessary for our daily needs. So from one place to another. So for making a boundary in our project in case of shopping malls, hospitals, colleges, etc. So for this, we have to apply our physical strength to push or pull this trolley. So which will be a very tedious task, especially for old age people and some others, etc. So to solve this problem, we are going to introduce a new model that is an automated human following trolley. And we have used some image and video processing algorithms to solve the above problem. So which we will be discussing in the further upcoming slides.
I think you got a very quick introduction about our project. Moving on further, the problem statement which we have chosen is in the present day technology, in various scenarios or in various places like hospitals, malls, colleges, etc., you have been seen a trolley which is manually pushed. It feels very difficult for some old age people to push or to apply their physical strength, and in hospital scenarios the staff nurse have to push or pull the trolley with their own efforts, and also they have to treat the patients. I think you have been visualizing both the scenarios in the videos which is present in the slide. These things may find difficult for them. So we have chosen this point or this point of pushing or pulling the trolley manually as one of our problem and major issue. And this is we have considered this thing as a problem statement and we have found a solution for it.
Yeah, coming to the literature survey part of our project, the first paper we have is a design and development of human following trolley. So it was published in the year 2019. The proposed work was this paper said that it represents the human following trolley using RPI, that is Raspberry Pi. It automatically avoids the obstacle and interacts with the person. For this, the technology or methods used are Raspberry Pi with a small Pi camera is also used. They used ultrasonic sensors in the trolley. Also used motor drivers and IoT technology which was implemented to solve the problem. So, implication part is that from this paper we came to know that using Raspberry Pi and Pi camera we could design a human following trolley. So similarly, coming to the next literature survey paper, design of the human followers trolley robot based on object tracking, that is using color detection method. This paper was also published in the year 2019. The main objective is to transfer the goods from one place to another by detecting the color of the cloth from the human and follow them. Web cameras as a sensor and ultrasonic sensors are used to detect the color and to measure distance of the user from the trolley was the methods that were used. So coming to the implication parts, here from this paper we understood that we can use ultrasonic sensors to measure the distance between user and the trolley. So coming to the next part of the literature survey.
Coming to next paper, trolley follower for hypermarkets. By using kinetic sensor and depth data and skeletal data and microcontrollers, the trolley is made to follow the user. The kinetic sensor is used for collision avoidance and used to maintain equal distance between the user and the trolley. Using from this paper, we came to know that we could use hip joint data of the user and which can be used as an input for the robot to follow. Coming to next paper, it is an automatic shopping cart using Raspberry Pi. Here, automation of building system in shopping malls is achieved by avoiding standing in long queues. Using RFID tags and readers, the items are scanned and displayed in the LCD monitor fixed on the top of the trolley. This project was not human following trolley, but it makes the trolley to be smart, which makes the billing automatic. So for future enhancement of our project or our trolley, we can implement this, giving our trolley more utilities.
Yeah, moving on into the next paper, that is the automatic human guided shopping trolley. So with smart shopping system. Yeah, this paper was published in the year 2014. So the proposed work in this paper says that there will be a line drawn all over the shopping mall, and the map of the entire mall is already fed into the trolley. That means, for example, so consider an example. So it guides the user like if the user wants to buy a sugar. So the sugar is present in this direction. So for searching the sugar, it should go straight and take left likewise. And for searching salt, so it should go left and then straight, etc. So all those things are fed already inside the trolley. And if the user wants to purchase sugar, it routes him towards the sugar direction. So then by following the map which is shown already, so makes the user to access the items very quickly and shop fastly. So this is how the proposed work in this paper or the methodology works. So coming to the implication part. So we got a overview of the entire project that we can also implement it in our project by feeding the entire map of that shopping mall, so for the future enhancement, if we implement this smart billing system, it might be very helpful. So, and the next paper is Follow Me Multifunctional Automated Trolley. And this paper was published in the year of 2017. So the proposed work here says, so here it is a simple line follower trolley is implemented, and it has a smart billing system and has a very good UI interface. So there was an Android tablet provided to the trolley here. So and using that all the payments and all are done. So these payments are also displayed there only. So this was all about the proposed approach. So here the implication part is that if a trolley following a line, so then why can't we make it to follow the human? So we got a beautiful motivation from this is that we could make our project by making the trolley to follow the human by using the human data or the user data. So this was the implication part of this paper.
Yeah. The next paper which we had referred is Smart Trolley, which was published in the year 2016. As the name of or the paper says that smart trolley, the trolley should be smart. The proposed work of this paper was the trolley is designed to automate the billing system or the billing processes performed by the customers. This saves the customer's time, etc. That was their thought. And each customer process billing system was locally fed into the trolley or it was performed locally. And how it was performed means the methods which they were using are some WSN, that is wireless sensor network technology, was used to perform this locally, and some protocol called as Zigbee protocol was used to automate the entire building system of that shopping mall. And what could we implicate or what could we get from this paper is suppose if we use this Zigbee protocol, we can also automate this billing system in the shopping malls, as we have set our boundary as a shopping mall. If we provide an automated human following trolley, in further or in future, we can implement this Zigbee protocol in shopping mall and also make the billing system trolley should follow the human automatically. It also reduce the human got paper. And the next paper which we refer is Hospital Nurse Following Robot, and it was published in the year 2014. And this paper, as the name is as the name itself says that Hospital Nurse Following Robot, and it is one of the other domain which we had set as a boundary, hospital. In hospitals, the proposed work in this paper, the proposed work says that the hospital nurse following robot with obstacle avoidance, which could carry about 20 kg of load, was designed from them. And for this, what they had used is they had developed a mobile platform using sensors, and integrating all those sensors, they were making that trolley to follow the user or the nurse. And what was the implication means we could use some ultrasonic and sonar sensors to avoid the obstacles. That is one of our objective in the further we will be discussing about it. This is what we got from this paper. Moving on further.
We can see in the images, in the first image, it is using ultrasonic sensor to calculate the distance between human and the trolley. In the second image, instead of ultrasonic sensor, we could make use of IR sensors or kinetic sensor to sense the motion of the user and follow him. These different sensors were attached to the trolley and make the trolley to move. This was the existing system. What we could get from this system is everything is designed to work using these sensors values. Trolley was following the user. Even if the sensor fails, there could be a problem for the entire system. This was one of the disadvantage, so we have proposed a new approach.
Yeah, coming to the proposed approach, here in a proposed approach, we have designed a trolley that follows the unique sticker provided for the user to detect and recognize and also maintain constant distance between the user. Only a single camera is enough and it is only used. How exactly it's going to happen is that we will be providing a unique sticker for each trolley, and for each trolley sticker, pattern and sticker color will be varying. Only that sticker is detected by that trolley and it will follow the same sticker present in front of the camera. If not, it will not follow. So this is what we have designed in our project.
Yeah, this was about the proposed approach and the existing system. Moving further, the objectives or the milestones which has to be achieved to solve the problem or to solve according to our approach was: first one, to design human following trolley using image and video processing. Yeah, you might have a question that the design part may not come to your domain. Why you have chosen that as an objective? Yes, the design plays a very vital role in our project, because if the design things fails, every other thing fails. I could quote that this is one of the foundation for the project. In our project, we have considered this design as one of the major protocol that should be followed to achieve the goal. That is, if the placement of the camera, maybe the placement of this Raspberry Pi, that is the microcontroller, or the carrier, how much it should carry, all those things matters a lot. So we have considered it one of the objective.
Yeah, so after the design comes the detection part. The detection of the sticker from the input image and video by eliminating background and noise. Here, detection of the sticker is nothing but a sticker will be provided for each trolley and having a unique sticker which has to be identified and then followed. As I mentioned, this sticker will be provided for the user. If the sticker is detected, then only the user is detected and then recognized. So it plays an important and major role in our project. So we have considered this as one of the objective. So moving on to the next objective.
Yeah, the next objective is that the recognition of the detected user to be followed. As we have just detected the sticker, the next comes the recognition part. So recognition is nothing but the detected sticker should be recognized by the trolley. That is, the trolley should know whom it should follow. If there may be many disturbances, like there may be many persons who are roaming in front of the trolley, or any sticker if comes in front of the trolley, so that should not be recognized. So there should be correctness in the following. So we are using this recognition of the detected sticker, which is nothing but the detected user. And hence, we have considered it as one of the major objective, since it is the main part in our project.
Next objective is maintaining constant distance between user and the trolley by avoiding collision. Every person does not have same walking speed. Trolley should not be collide with the user when there is difference in walking speed of the person. So in order to avoid such collisions, it has to maintain some constant distance from the user. So we have made it as one of our objective to avoid collision situations.
Coming on to the methodology section, it is generally a quick overview of our entire working of our project, and it also includes what are the different techniques which we have used, how exactly the flow works, all those things. Yeah, firstly, as you can see, so the system will start to capture the image. So the camera will start to capture the image or video which is in front of it. Next comes the detection part. As we have said, as one of the important objective is the detection. Actually, here, detection of the sticker from the captured image is being performed. So what we have planned is a unique sticker will be assigned to the trolley, and that sticker will be provided for that user, for the user who wants to use that particular trolley. The sticker may be like some green or red colored symbols, etc. As of now, we have planned to give the green colored sticker for the detection and recognition purpose. So this sticker is provided to the user, and this sticker should be shown to the camera, and it captures the images, and by using some detection algorithms, the sticker will be detected. Recognition of the sticker will be the next phase. That is, once the sticker is detected, every time when there is a sticker in front of the whenever there will be a sticker in front of the trolley, so the sticker should be recognized. I mean, there may be many disturbances, like as I told earlier, there may be some other stickers or some other persons who are roaming in front of the trolley, so it should not be it should all be considered as junk values, and it should be neglected. So only the detected sticker should be recognized and followed. And here, so we have used some of the algorithms to do so. Next, the trolley should follow the user by maintaining a constant distance. So as we have said, as one of our objective to avoid the collision by maintaining the constant distance. So for this, we have used some distance estimation techniques. So for the trolley to maintain a constant distance between the user and the trolley, these techniques will be used to achieve the constant distance between the user and the trolley. So then once the use of the trolley is finished, so it should be stopped, moving the detected sticker away from the trolley, which means the system will going to stop. So this is all about the methodology, or how the data flow or the work process of our entire project is. Moving on further.
Yeah, coming to the algorithms we have used here, the first algorithm I'm going to explain is background subtraction algorithm. So here what here happening is we have used to achieve those objectives, and one of the important algorithm is background subtraction algorithm. We might have some idea regarding background subtraction algorithm. Here there will be a input image, and giving a quick overview of this background subtraction algorithm, the part which has to be detected is present with other background present in that. So the first it will be pre-processed, then a background modeling will be happening, and only the part that has to be detected is considered as the foreground, and rest other things will be considered as the background, and foreground will be masked and considered for processing. This is how a background subtraction algorithm works, and in our project how we have implemented this is a sticker is given and considered as a foreground part. Only those things should be recognized and detected, and for further process, and rest other things will be present in the video frame or camera frame should be considered as a background. So this is how a background subtraction algorithm is implemented in our project.
The next technique which we are used or which we are using is determining the HSV value of the sticker. Yeah, to detect the sticker, we have to determine or we have to recognize what is the value of that sticker, and it could be calculated by determining HSV value. Obviously, there are various other models like RGB or CMY color model, but why HSV means the HSV stands for hue saturation value. This HSV technique has got very different approaches, and it has got from 0 to 360 degrees of different colors. But in RGB and CMY, there are only 3 different colors and its variants. In HSV, there are both RGB color variants as well as CMY color variants. Hence, HSV is more precise and more relatable to human eye. So we are using this HSV value for detection. And the other image is showing that the blue color dots or the blue colored area is detected. If we give the value of this blue color HSV value for the program, it will only detect that blue color, and the rest of the things are considered as the background, and it will be subtracted. Only the blue colored area is masked and it is kept for further processing. This is how the background subtraction algorithm is working in our process, as said by Hemanth, Bharath, Bhushan. And this HSV technique is used to do such process in our project.
Euclidean distance estimation. To give the quick overview of the algorithm, this is used to calculate the distance between user and the trolley. Why we are using this algorithm is to avoid the collision between user and the trolley. Here is the formula for it. X and Y are the coordinate values of the camera and the object. In our project, how we are implementing is Here we have used a yellow cardboard. So this algorithm calculates the distance from that cardboard to the camera, and we have fixed the distance to 1 meter. This will be calculated for every image taken from the camera. Once the object is out of 1 meter distance, trolley moves forward until the distance becomes 1 meter, and it stops at the distance 1 meter, avoiding any collision. This is how the distance estimation works in our project.
So, in order to briefly explain how our proposed approach is better when compared to the existing approach, so we are going to tell you a brief about the comparison between the existing and the proposed approach. So, in the first point, you can see that in the existing approach, as you have seen in the previous slides, the approach was using the kinetic sensors to detect the motion of the user, and then it is moving according to the detected or sensed values. But in our proposed approach, only a single camera is programmed to capture the image of the user and to detect him. So there is no necessity of the kinetic or other sensors. So this is one of the advantage of our project. So the next point is that, so in the existing system, so here an ultrasonic sensor is used to maintain a constant distance between the user and the trolley. So as earlier we have seen in the earlier, so in the literature survey itself, we have mentioned that an ultrasonic sensor is used to calculate the distance and maintain the constant distance. But in case of our project, we have used a single camera and we have coded it to maintain a constant distance in order to avoid the collision. So it is well enough so that using the program for the replacement of this and for in using by replacing the sensor, it is very good that we are replacing our entire hardware by implementing it in the software part. I think this is one of the best approach so than the previous existing approach.
So coming to the third comparison between existing and proposed approach, there were many sensors implemented. If a single sensor fails, the entire system would fail. So as said by Likith, were ultrasonic sensors and kinetic sensors, and actually in existing system, we had also shown some images consisting different sensors. This clearly shows that if every sensor worked, then only the project was well and good and successful. If a single sensor fails, then there is a chance that entire system will fail. Suppose consider a scenario, the ultrasonic sensor fails in working and at that time the collision may happen. But in our proposed approach, we are using single camera for the replacement of all those sensors. Hence, there might be no failing of sensors or any issue on the systems. Thus, our proposed approach is much better than previous approach.
Ah, the next thing is obviously in the existing system had very huge amount of sensors in it. That means maybe the kinetic sensor or motion sensor or ultrasonic sensor, etc. Obviously, if there are more number of hardware parts, the cost also will be more. But in our proposed approach, the number of hardware parts is very less. Only the camera is replacing all those sensors. So I think the cost will be comparatively less than the existing approach. So I can quote that our proposed approach is better than the existing approach.
Coming to the next comparison, it receives more power as a multiple sensors are used. Since these sensors takes more power to work, I think the existing system, it consists of different sensors, and since every sensor requires power to work, this affects the rate of the power consumption of the processor also. This might cause a delay in the project. In our project, only camera and motor are consuming the power. So comparatively, the power supply is more for the Raspberry Pi, allowing it to work at higher capacity, reducing any delays. So our project is more efficient and effective comparing to these previous approaches. Sensors may occupy large amount of data or space, reducing space for a carrier. You can see if we are using more hardware devices, it occupies more space. Since previous systems were purely sensor based, they were using at least 2 to 3 sensors and processing units. And to connect these components, they were using breadboards, etc. All those things were occupying more space in our project. In our project, since we are using single camera, the processor is occupying less space comparatively. So the carrier size can be increased for more space. So this is one of our add-on to our projects. Coming to the results, since we have taken this designing asset trolley as an objective, here is an images of the design of our system. You can see different views of our basic model, which is working efficiently. This trolley consists of two normal wheels and one caster wheel, and chassis is provided for the trolley. Upon the chassis, camera is mounted in front of the trolley, and the carrier is placed in the backside of the trolley. And we have tried various other designs like placing the camera back and carrier in front to move in opposite direction. In all those designs, this design was more feasible, and the Raspberry Pi is also given to the trolley, and the motor driver IC is placed under the trolley, which takes the input from Raspberry Pi and amplifies that signal and provides it to the motors. Moving on to next slide.
Yeah, coming to the detection process of this project. As discussed in the previous slide, a unique sticker will be provided for each trolley, and this sticker will be held by the user using the trolley. If the sticker is present in front of the camera, and the algorithm written inside the camera is that it should capture those videos or images regularly, and it will detect the sticker which has provided for it, and the rest other things are considered to be background. You can see in the images that this for this illustration purpose we have given this yellow colored sticker as an input for this detection process, and we have kept it in front of the camera. You can see the first window is showing the input view of the system. It is capturing whole frame, and in that frame you can see my hand and other background things like photo frame on the wall, etc. But the second window is showing the HSV image of the first window. As said by Hemanth, we are extracting HSV value of that input image, and we are applying some procedures on that HSV values and making it to detect. And the third screen is showing the final result, which consists of the only yellow region which has to be detected, and the last is the mask value. In the input frame, it will consider rest other things and as the background, and one consider this yellow color sticker as the foreground and mask it, provided for further processing. And this is the result of the detection process.
Moving on further, you can easily observe in the video that, as Hemant said in the previous slide, only the yellow colored region that has to be detected will be detected by the trolley. And suppose if other trolley if or other user comes in between, see, you can see that he is holding a red colored sticker or red colored thing. It is not detected by the trolley. You can observe it clearly. So it is very feasible that there might be no chance of collision with the other users or other trolley. This is how the recognition process works in our trolley. Moving on further,
Maintaining a constant distance. As we had discussed, and as we have said was one of our objective that the trolley should maintain the constant distance from the user. This is because, as we know, every human being cannot maintain a constant pace in walking. And if the user suddenly stops, in return, the trolley should respond to the user's action and it should stop. Sometimes there may be some accidents, so that is, the trolley might collide with the user itself. To avoid such things, this technique, that is the distance estimation technique, is being performed. Each and every movement, so from the input image, so which is captured from the camera, so we will be calculating the distance of the user or the sticker from the camera, and we have fixed a constant distance so that upon this distance should not vary, and if this distance becomes less, the trolley should stop and avoid the collision. So this is what the distance estimation plays a major role by avoiding the collision between the user and the trolley. And suppose if the user stops and comes backward suddenly, then also the trolley should not stop there itself. It should also react to the user's action, and it should also come back. So you can see in the video, the trolley is moving front. If the distance is more than the threshold distance or the stopping distance, so and it stops at that threshold distance. So, and if the user comes backward, the trolley is also moving backward to maintain a constant distance, thus avoiding the collision.
So to conclude the whole project or the presentation, you had been gone through various sections like introduction, problems we are facing, what was the previous approaches to solve this problem, how we are solving, etc. Now coming to the conclusion part, where our proposed approach is better and adding the proposed approach is better compared to previous approach. That is, we are using a single camera to perform all the actions. We have also implemented a distance estimation technique to calculate the distance of the user from the camera to or the trolley. So this in turn avoids the collision between user and trolley. This is one of the major advantages of our project also.
Background suppression algorithm implemented for detection and recognition purpose has increased the performance of our system. We had shown and explained how background suppression and why it has been used in our project previously.
Determining HSV value of the sticker rather than the RGB or CMY model increased the performance of our system. This was clearly explained previously. To conclude, HSV is better than the RGB and CMY model.
Presently, we have designed the basic model, and for future scope of the improvement, we can implement this model or procedures in various other environments and even in various places. So the next is, in this project, we had set a boundary. So that is in shopping malls or hospitals. Not only in these areas, we can also make use of these trolleys in schools, libraries, etc. And all these things have in common that they have a flat or even surface that are present in these cases. So our trolley will work efficiently in all these cases. But some parts of the design could be changed or altered according to the demand of the environment.
This project can also be implemented in other various fields where there are uneven surfaces like agricultural fields, war fields, etc. But there we have to use large wheels, or we could add some other very efficient algorithms. This is what the whole thing to conclude for our project. Thank you.
Hello, I am Hemanth from Maharaja Institute of Technology, Mysuru. Now, I am going to explain you about my final year project, that is automated human following trolley using image and video processing. Before explaining my project, I have to introduce my teammates, that is Hemanth, Bharath, Bhushan. Hi. And my second teammate is Kishore TC.
Hi.
And my other teammate is Likith V.
Namaste.
Getting into the topic, first let's discuss about the problem statement which we have chosen for our project. Yeah, in the real scenario, you might have observed in the shopping malls or maybe in hospitals, in various areas, we use trolleys to carry the goods. In hospitals, maybe the medicines, etc. Or in the schools, maybe we might use the trolley to carry the books or internal papers, etc. In this scenario, we use our physical strength to push or pull the trolley. If you consider a scenario, old age people may face difficulties in pushing or pulling this trolley to apply their physical strength in the shopping malls or etc. And in the hospitals too, the staff nurse have to push or pull the trolley using their own physical strength, and also they have to treat the patients. It might find difficult for them too. In order to avoid these difficulties, we have choose a solution for it. And what is the solution for the problem is, what we have thought is, might be we can design a trolley which could follow the human automatically without using their physical strength. And how it is possible? Yeah, this is what we have figured as a solution for the above problem. And it is nothing but applying some image and video processing algorithms to the camera, and this camera records the user's movement and follows the user. This is what the solution which we have chosen, and we will demonstrate it in the further things. Before it, what are the objectives, or what are the some constraints, or what are the main or important things which we have to consider to design or to make this as a solution for the above problem? One of the major objectives, design a human follower trolley. Yeah, design, it means what exactly the specification of the trolley, maybe its height, weight, or its capacity, all those things is considered as the design thing. And the second objective is nothing but detection of the human. Nothing but we will provide a sticker for the human. This sticker will be unique for unique trolleys. So detection of the sticker, it is the second objective. And third objective is recognition of the human to follow. This is our third objective. And fourth objective is maintain the constant distance from the user and the trolley. These are the four constraints or four objectives which we have considered to solve the above problem. Moving further, my teammate is going to explain you more about the design of the trolley.
So here we have mounted a camera, and this camera is called as a Pi camera. Here what this Pi camera is, it has a resolution of 640 into 480 pixels. Yeah, so coming to this, this is recording what is in front of the camera and gives it as an input to a microcontroller. Coming to the carrier part of the trolley, the carrier has a length of 12 centimeter, breadth of 8 centimeter, and height of 6 centimeter. In volume, it has 580 cubic centimeters. Yeah, so this is how a trolley we have designed. Coming to the wheels of the trolley, it consists of 3 wheels, and a front wheel is called as a caster wheel, which can rotate to 360 degree any direction all around. Next, coming to the next 2 wheels are called as a BO wheels, which can rotate and is controlled by a L293 motor driver IC. Yeah, these wheels are attached to a BO DC motors. Coming to the next part of our project, we have given a signal to this L293D motor driver IC using a microcontroller called Raspberry Pi 4. The configuration of this Raspberry Pi 4 goes like this. It consists of a camera port, which is called as a Pi camera port, which is inbuilt to the Raspberry Pi, and this is used to give an input from the camera to the Raspberry Pi. Coming to the next configuration, a Raspberry Pi consists of 40 GPIO pins, where these GPIO pins are used to give the signals to the L293 motor driver IC and to control the trolley. This is the display port that is given to an inbuilt Raspberry Pi to connect an LCD monitor to the Raspberry Pi. These two are the HDMI ports that are used to connect to a display of the computer. This is the main power supply that is given to the Raspberry Pi to enable it. So finally, it consists of 2 USB ports, and which is of 2.0 configuration, and 1 USB port of 3.0 configuration. This is an Ethernet port that is used to connect the LAN and WAN to my Raspberry Pi. This is a power supply called as a power bank that is given to the Raspberry Pi, and it takes a power input of 5 volts and 3 amperes precise.
Before showing the live demonstration of our project, I would like to give an idea how it works using a scenario. Consider this is a user and this is a trolley. We have to think, or I have to give an idea that how this trolley will follow the user, how it follows his commands, or how it is following him using this video. Now the user is moving forward, and obviously the trolley is moving forward. If the user wants to go back again, see, the trolley is also moving back. And if there is a turn and user wants to turn left, see, the trolley is following him and it is also turning left. Again, if the user wants to move right, in this scenario also the trolley is moving right by following him. You saw how the trolley is responding to the user, and not only that, in our project it is maintaining the constant distance from the user. This is just because to avoid the collision between the trolley and the user. Coming on to the working procedure, first we have to eliminate the background and detect the sticker which is provided for the user. So you can see in the camera, the first window is showing the camera which is taking the input, and what are the things present in front of the camera it will take as input. You can see here is my face, and now we have coded that it has to detect only the yellow colored region, that is the sticker which is provided, and it has to mask it for the further processing. And you can see in the another window it is taking the HSV value of the input which is coming through the camera, and another window is showing the output. Only the yellow colored region is considered in this window, and the next window is showing the masked region, that is the detected region, which it has to follow or which it has to be processed for the further things that is considered to be a user, which the trolley should follow. So this is how the background subtraction algorithm is working in our project. This is what you are seeing is the terminal output of our project. Suppose the trolley is how it is working, how it is following the user. Now there is no object, that is the sticker which has provided for this trolley is not present in front of it. So it is still searching for that sticker. If the object comes, see, the object is nearer to the trolley. If it is moving towards the trolley, hence the trolley is moving backward. You can see that in the screen. And if the user moves further and he stops to purchase something, the trolley is also stopping. After he takes everything, he moves forward. It is, if the user moves towards right, yeah, it is moving towards right. That is, you can see the right is coming. And if he is away from the limit, it is searching. User moves towards left, yeah, the trolley is moving towards left. This is how it works.
Before giving a live demonstration how the trolley works, I would like to show you how the trolley follows the commands of the user, and this is how it goes. So consider this sticker as the user. When the user comes in front of a trolley, the trolley moves forward. As you can see, both the wheels are rotating. If the user stops, the trolley maintains a certain distance and it also stops. This will be the random distance. If the user comes backwards, the trolley is also moving backwards. You can see the wheels rotating backwards. So if, for example, if the user is moving forward and then suddenly turns to the left, so the trolley is also responding and it turns left, where the left motor turns backwards and the right motor turns forward. If the user goes to the forward and then goes to right, you can see the trolley of the wheels of the trolley is moving forward, and it is also following the commands. It is also turning left and right. So this is how a trolley follows the sticker when it is given to the user. So now you have seen how trolley follows the user, but just in case if you consider some other person enters in between the following trolley. So this is the sticker, and the for trolley is following the sticker. Just imagine this as one more sticker and it comes in between the trolley. So you can see there is no collision, and the trolley is also stopping there and searching for the current user. So if it detects the current user, then only it follows the user. But if another user comes in between, the trolley stops and it does not follow, or nor it does not collide, and it does not follow the commands of that user. So this is how we have designed the trolley when another user comes in between.
See, moving on to the live demonstration of the project, see, here is the trolley and it has to follow the user. Consider the user is here, and for each trolley we will be providing a unique sticker, and it is given to the user. He is standing here with the sticker, and we have fixed a distance. This is called as forward distance. Now if the user is moving further, see, the trolley is moving forward. Now once the user moves backwards, the trolley moves backwards. See. Now if the user moves right, the trolley is moving towards his right. See. See, the trolley is moving towards left. It is the stopping distance. Here the trolley stops without collision, and if it moves backward, it is moving backward. And if the user is moving left, see, it can turn left also. And if there is no detection of yellow color, assume there is a black color. See, there is no detection, it is not moving. So I can clearly say that if only the detector sticker is present in front of the trolley, it will move. See, again, it is stopping here. If the user is going back, it is moving back. If he is going towards left, it is turning left.
You have gone through our project and also you have seen the working model of it. I think you have understood how our project works. So to put on the final conclusion for this video, I have to add some points. So till now we have built only the basic model and it is efficiently meeting all the desires that we had set earlier. For the future enhancement, we could use the following points for it. So in the real time. So by making the design of the trolley as suitable for the environment and by using an efficient power supply. So we had set a boundary for our project. That is, we limited its working only in shopping malls or hospitals environment. Basically, which has a flat surface. We could enhance its use in other fields too. That is, agricultural fields or maybe in war fields which has uneven surfaces. So for this, we could use a large wheels and effective power supplies, etc. So at present, our project performance is good enough. Still, if you want to increase its performance, we could use a high-level processors, high-resolution cameras, etc. Yeah, that's all about it. Thank you for watching this video.